Hi everyone, in this video we will understand the solid principles which form the foundation for learning design patterns. As we saw in the previous video, SOLID is an acronym that stands for S for single responsibility principle, O for open close principle, L for Liskov substitution principle, I for interface segregation principle, and D for dependency inversion principle. Now let's understand each of these principles in detail with simple analogies and code examples. Let's start with single responsibility principle. So single responsibility principle says a class should have only one reason to change. Let's understand that with an example. Suppose in a restaurant a chef is doing all the stuff, cooking, taking orders, doing the dishes and delivering food. Imagine the time it will take them to do any task on time. Imagine the mess they will create. That is a bad example of single responsibility principle. Now imagine we have a separate person for each task. A chef to cook, a waiter to take orders, and a cleaner to wash the dishes. The restaurant runs smoothly and everyone knows what to focus on. That is what the single responsibility principle is all about, giving each class one clear job. As we can see, the class chef does the cooking, takes the order, delivers food, and washes the dishes as well. This class has multiple responsibilities, which makes it hard to manage or update. This is the better approach. Instead of one class doing everything, we split the responsibilities into separate classes. Now the chef only cooks, the waiter only takes orders, and the dishwasher only handles cleaning. Each class has a single reason to change, which is exactly what the single responsibility principle recommends. The next principle is open-close principle, which says software should be open for extension but closed for modification. Let's understand that with an example. Think of a mobile app that sends only emails and SMS. If you want to add WhatsApp alerts, you should not rewrite the whole thing. In this code example, if we want to add any other form of communication, we will have to change the already tested and deployed code, which is never a good idea. Instead, we should create an interface. Then whenever we want to support a new communication method, we can simply implement that interface. This way we extend the functionality without modifying the existing code. Let's explore the next principle in SOLID, Liskov substitution principle. Liskov substitution principle says object of a superclass should be replaceable with objects of its subclasses without breaking the program. Let's understand that with an example. Think of a TV remote. It should work the same way with any brand of TV. If one TV doesn't respond or behave differently, it breaks your expectations. That's what happens when a subclass doesn't behave like its parent. This is a code example of Liskov substitution principle. We have an interface remote control that is our parent class. Then we have Samsung TV and LG TV. Both of them are implementing that remote control interface, which makes them subtypes of remote control. Now in the main method, we can see remote 1 and remote 2 are declared as remote control. We can substitute them with any implementation, Samsung TV or LG TV, and the program still works perfectly. Let's understand the next principle, interface segregation principle, according to which a class should not be forced to implement methods it doesn't use. For example, suppose you are applying for a software job, but the form also asks you if you can fly a plane or have watched all the seasons of Game of Thrones. It's irrelevant. A class should only be asked to do what it actually needs. Let's look at the following code. Here we have an interface called job application that includes a couple of unnecessary methods. Any class that implements this interface is forced to define all of its methods, even if they don't make sense for that specific role. Imagine how much extra and meaningless code we'd have to write and maintain if we had multiple interfaces like this across our code base. This violates the interface segregation principle. Now let's see this code. This is a much better design. The interface contains only one method, the one that's actually relevant to the role. The software engineer class only implements what it truly needs, uploading a resume. This makes the code simple, clear, and easy to maintain. No extra methods, no irrelevant responsibilities, just one class doing one focused job. Let's come to the last principle of SOLIDS, dependency inversion principle, which says high-level modules should depend on abstractions, not on concrete implementations. Suppose you have built a text editor that works with .txt files. Now your boss asks you to support JSON and MD extensions too, because the specs always change. If your code is not able to handle that, it's too tightly coupled. In this example, the editor class is tightly coupled to specific files like .txt and .json. It knows exactly which parser to call, which means it is directly dependent on low-level modules. This violates the dependency inversion principle, which says high-level modules like editor should depend on abstractions, not concrete classes. To fix this, we introduce an interface called file parser. Let each file type handle its own parsing logic. Now the editor only depends on interface, making the design more flexible and easier to extend. Thanks for watching. Like and subscribe for more content like this.